while back from the gravitational breakdown of a monster interstellar subatomic cloud. By far most, 99.86%, of the framework's mass is in the Sun, with a large portion of the leftover mass contained in the planet Jupiter. The four inward framework planets, Mercury, Venus, Earth and Mars, are earthly planets, being made fundamentally out of rock and metal. The four monster planets of the external framework are significantly bigger and more huge than the terrestrials. The two biggest, Jupiter and Saturn, are gas monsters, being made predominantly out of hydrogen and helium. The following two, Uranus and Neptune, are ice Goliaths, being made for the most part out of unstable substances with generally high softening focuses contrasted in hydrogen and helium, like water, alkali, and methane. Every one of the 8 planets have almost round circles that lie close to the plane of Earth's circle, called the ecliptic. Inside 50 million years, the tension and thickness of hydrogen in the focal point of the protostar became extraordinary enough for it to start nuclear fusion. 19. The temperature, response rate, strain, and thickness expanded until hydrostatic balance was accomplished, the warm strain offsetting power of gravity. Right now, the Sun turned into a primary grouping star. 20. The fundamental succession stage, from start to finish, will go on. Around 10 billion years for the Sun contrasted with around 2 billion years for any remaining periods of the Sun's pre-leftover life combined. 21. Sun-powered breeze from the Sun made the heliosphere and cleared away the excess gas and residue from the protoplanetary plate into interstellar space. As helium collects at its center, the Sun is developing brighter wink with a frown. 22. Right off the bat in its fundamental grouping life, its splendor was 70% that of what it is today. 23. The nearby planet group will remain generally as it is known today until the hydrogen in the center of the Sun has been altogether switched over completely to helium, which will happen around 5 billion years from now. This will stamp the finish of the Sun's primary arrangement life. Around then, the center of the Sun will contract with hydrogen combination happening along a shell encompassing the idle helium, and the energy result will be more noteworthy than as of now. The external layers of the Sun will grow to multiple times its ongoing measurement, and the Sun will turn into a red monster. In view of its expanded surface region, the outer layer of the Sun will be cooler, 2600 K, 2330 degrees Celsius, 4220 degrees Fahrenheit, at its coolest, than it is on the primary sequence. 21. The growing Sun is supposed to disintegrate Mercury as well as Venus, and render Earth appalling, potentially obliterating it too. In the end, the center will be sweltering enough for helium combination. The Sun will consume helium for a negligible portion of the time it consumed hydrogen in the center. The Sun isn't adequately enormous to start the combination of heavier components, and atomic responses in the center will wane. Its external layers will be catapulted into space, abandoning a thick white midget, a portion of the first mass of the Sun yet just the size of Earth. 24. The shot-out external layers will shape what is known as a planetary cloud, returning a portion of the material that framed the Sun, yet presently improved with heavier components like carbon, to the interstellar medium. 25. Construction and creation. Additional data, rundown of planetary group items and planetary traits. The word sun-based signifies, relating to the Sun, which is gotten from the Latin word sol, meaning Sunday. 26. The Sun is the predominant gravitational individual from the nearby planet group, and its planetary framework is kept up within a generally steady, gradually developing state by following confined, gravitationally bound circles around the Sun. 27. Circles. Movements of the planetary group's internal planets and external planets circling, the last liveliness is multiple times quicker than the previous. Jupiter is multiple times as distant from the Sun as Mars. The planets and other enormous articles in circle around the Sun lie close to the plane of Earth's circle, known as the ecliptic. More modest cold articles, for example, comets habitually circle at fundamentally more prominent points to this plane. 28. 29. The greater part of the planets in the planetary group have optional frameworks of their own, being circled by regular satellites called moons. A considerable lot of the biggest regular satellites are in simultaneous pivot, with one face forever moved in the direction of their parent. The four monster planets have planetary rings, slight groups of small particles that circle them in unison, 30. Because of the development of the planetary group, planets and most different items circle the Sun in the very course that the Sun is turning. That is, counterclockwise, as seen from over Earth's North Pole. 31. There are special cases, for example, Halley's Comet. 32. The majority of the bigger moons circle their planets in prograde heading, matching the planetary pivot. Neptune's moon Triton is the biggest to circle in the inverse, retrograde manner. 33. Most bigger articles turn around their own tomahawks in the prograde bearing comparative with their circle. However, the revolution of Venus is retrograde. 34. To a decent first estimation, Kepler's laws of planetary movement depict the circles of items about the Sun. 35. 433 to 437. These regulations specify that each article goes along an oval with the Sun at one concentration, which makes the body's separation from the Sun fluctuate throughout the span of its year. A body's nearest way to deal with the Sun is called its perihelion, though its most far-off point from the Sun is called its aphelion. 36. 9 to 6. The circles of the planets are almost round, however numerous comets, space rocks, and Kuiper belt objects follow profoundly curved circles. Kepler's regulations just record for the impact of the Sun's gravity upon a circling body, not the gravitational pulls of various bodies upon one another. On a human time scale, these extra irritations can be represented utilizing mathematical models. 36. 9 to 6. However, the planetary framework can change turbulently north of billions of years. 37. The precise energy of the planetary group is a proportion of the aggregate sum of orbital and rotational energy moved by all its moving components. 38. Albeit the Sun rules the framework by mass, it represents just around 2% of the rakish momentum. 39. 40. The planets, overwhelmed by Jupiter, represent a large portion of the remainder of the rakish force because of the blend of their mass, circle, and distance from the Sun, with a conceivably critical commitment from comets. 39. Structure. The general design of the graph districts of the planetary group comprises of the Sun, for more modest inward planets encompassed by a belt of, for the most part, rough space rocks, and 4 Goliath planets encompassed by the Kuiper belt of, for the most part, cold items. Cosmologists here and there casually partition this design into independent areas. The internal planetary group incorporates the 4 earthly planets and the space rock belt. The external planetary group is past the space rocks, including the 4 Goliath planets. 41. Since the revelation of the Kuiper belt, the peripheral pieces of the nearby planet group are viewed as a particular district comprising of the items past Neptune. 42. Contents. 1. Formation and advancement. 2. Structure and structure. 2.1 Orbits. 2.2 Composition. 2.3 Distances and scales. 3. Sun. 4. Environment and tenability. 5. Inner nearby planet group. 5.1 Inner planets. 5.1.1 Mercury. 5.1.2 Venus. 5.1.3 Earth. 5.1.4 Mars. 5.2 Asteroid belt. 5.2.1 Ceres. 5.2.2 Pallas and Vesta. 5.2.3 Asteroid gatherings. 6 Outer nearby planet group. 6.1 Outer planets. 6.1.1 Jupiter. 6.1.2 Saturn. 6.1.3 Uranus. 6.1.4 Neptune. 6.2 Centaurs. 7 Comets.
We cannot solve problems with the kind of